Hey everyone, we are going to focus on solving some equations today, getting a little bit longer, a little more complicated. So these are multi-step equations. We're still only working with the variable on one side. No big deal. Some of these will be pretty straightforward for you. We're going to practice our signs again. And also I want to point out just a couple of things that maybe we haven't seen before. So I look at an equation like number 1. I have 7 minus b minus 6. So there's a lot going on that left-hand side. Our rules today are going to be if there's anything to distribute, we're going to distribute. There won't be in these first couple equations. And then combine any like terms. And that's a pretty good pretty good set of rules for solving any equation. So get rid of any parentheses and combine like terms, not like equations. I'm trying to write and speak at the same time. Always want to do that. We want to simplify things, clean things up before we start to solve. Okay, so as I look at number 1, it says 7 minus b minus 6 equals 1. I need to think about my signs here. There is nothing to distribute, but to combine the like terms, that would be the 7 combining with, now this isn't 6, it's minus 6. 7 and minus 6 is 1 minus b equals 1. So every step I go down should be a little simpler than the step before. I want to get rid of this 1 that's attached to the b. Well, that 1 is a positive 1, and the way I'm going to get rid of it, eliminate it, to isolate the variable, is by subtracting 1, again, from both sides of the equal sign, okay, not just from one side, but from both sides of that equation. We've got to be careful here. That doesn't leave me with b on the left. It leaves me with the opposite of b, negative b, equals, well, actually, this just got a little bit easier because that's equal to 0 on the left. Here's the thing. When I say negative b, I really mean negative 1b. So to eliminate that negative sign, or to eliminate that negative 1, I could multiply by negative 1 or divide by negative 1. b will equal 0 divided by negative 1. That's still just 0. A lot of times our answers can be 0. That's okay. It's all right to have 0, the absence of value, as an answer. Okay, in fact, if I put 0 in here, 7 minus 0 minus 6, yeah, that's equal to 1, so I know I got the right answer. Let's look at number 2 now, another problem that involves 0. This one says negative 7 minus 3n equals 0. First step, again, distribute. There isn't any distributing to be done, so I'm going to go to combining like terms. Well, my like terms give me negative 10n equals 0. To eliminate that negative 10 that's multiplied by the n, I would divide by the negative 10. And again, coincidentally, like the first problem, I get n equals 0. And does that make sense? Well, we can check that back in the original equation. Negative 7 times 0 would be 0, minus 3 times 0, which is also 0, is equal to 0. So I'm pretty sure that's a correct equation. Let's look at number 3. In number 3, I have x plus 5 minus x equals 0. Again, nothing to distribute, but I'm going to combine the like terms. Well, my like terms here are x and minus x. And x and minus x are 0. So that net sum right there is 0. And what I'm left with on the left is 5 equals 0. Well, where do I go from there? There's no more variable, right? And in fact, 5 is not equal to 0. 5 will never equal 0. This kind of equation is called a contradiction. Sometimes we draw two little arrows that face each other. A contradiction. And what that means is that there is no number ever that will solve this equation. Let's go take a look back at the original equation. Can you think of a number that if you add 5 to it and then take away that number, you're going to get 0? No, because it's always going to be 5 more than 0. Some number, add 5, and they take the original number away. You're always going to be left with 5, which is not 0. That's called a contradiction, and what we say for an equation like that is that there is no solution. Okay? When we get down to the last line, there's no variable, and it's a false statement. 5 is not equal to 0. That's false. When we have a false statement, we say no solution. Now I want to contrast that with number 4. Number 4, if I combine like terms here, variables on the right, but that's okay. That 0 is equal to negative 3x plus 3x. Well, those do combine to 0. Negative 0 equals 0. Well, that is true. The variable's gone again here. That is true. What we say for a problem like that is that all real numbers will solve that equation. Think about that. Back in the original equation, no matter what number you put in for x, if you multiply it by negative 3 and then multiply it by 3 and add them together, you're always going to get that thing. You're always going to get 0. That kind of equation is called an identity. And the symbol we use for all real numbers is that capital R with the double bar. Any real number will solve an identity. Okay, so we have 3 things going on here. We have still a variable in the problem where the variable is equal to 0. That's our answer. If the variable goes away and the answer is, or the last statement is false, that's a no solution. If that last statement is true, that's an identity. We say all real numbers. So some fine tuning there on some pretty basic ideas, right? We can solve those 1 and 2 step equations pretty easily. But sometimes weird things happen and we have to be ready for that in Algebra 1. Okay, we move on here. We have some longer equations. Some of these pretty straightforward. You want to distribute first, combine like terms, and then solve. The difficulty here, like it always is going to be our signs. Number 5, this looks pretty straightforward because everything's positive. This should be an easy equation to solve. So I would distribute first. That's 18 plus 9a equals 81. Now I'm trying to isolate that variable. The variable is being multiplied by 9, and then we add the 18. So in reverse order there, I'm going to subtract the 18 from both sides. That's going to give me 9a equals 63, I believe. And then divide by the 9, and a should equal 7. And again, notice every line down, my equation got a little bit smaller so that I have that line at the end. All right. Be aware, I'm not going to do all of these, but be aware of a few things. Question like number 6. We need to follow the order of operations here. We do not ever do this first. We see 2 minus 5 and we're tempted to make that negative 3, but the order of operations says that 5 is being multiplied by the parentheses first. That's why we distribute before we combine like terms. Okay, don't do the 2 minus 5. First thing we want to do is distribute. So that's minus 83 equals 2 minus, now that's 10x, and watching our signs, minus 15. I've distributed, make sure my signs are right. I'm going to combine like terms. Nothing to do on the left side, that's negative 83 equals. So on the right, my 2 like terms happen to be the 2 and the minus 15. 2 and minus 15 make minus 13. So I have minus 13, and then I need to remember that that 10 has a minus with it, minus 10x. You also could have written, of course, negative 10x minus 13. We'll get the same answer either way. But be aware of your signs. That's the most important thing here, like it always is. Pay attention to signs. All right, now I need to solve for x. So I have this x is being multiplied by negative 10, and then this minus 13 is in there. So I'm going to undo the minus 13. The inverse of a minus 13 would be a plus 13. And again, on both sides of the equal sign. On the left here, let's see, that's minus 70 equals, and on the right, I can't ignore that minus sign. That is minus 10x. And then I'll divide by negative 10, divide by negative 10, and x equals 7. Okay, so they're getting a little bit longer. Have your head in the game as far as the signs go. All right, this is another one of these worksheets that the computer generated. The answers will be nice, neat integers, or no solutions, or all real numbers, so pay attention to that. I'll do one more with you, And then your homework will be just an attached PDF, 12 more problems, just focusing on your signs and organization. Okay, I'll do this last one here, number 11. There's a lot of sign stuff going on here. Equals negative 57. I don't know where that's coming from, but let's see how this turns out. So again, first thing I want to do is distribute. Negative 5 times m, negative 5m. Watching my signs here, that's negative 5 times negative 3 should give me a positive 15. If you get down to the end of an equation and it's really messy, go back and check your signs. That's probably where you went wrong. These aren't hard. You guys all know how to add and multiply. It's just a matter of the signs. All right, taking care of that first parenthesis, second parenthesis. 4 times 7, that's plus 28. And again, watching my signs, 4 times minus 5m would be minus 20m equals negative 57. So I've distributed. Next thing I want to do is combine like terms again, watching my signs. I have negative 5m and negative 20m. That gives me negative 25m. So that and that taken care of. 15 plus 28, I think, is 43, plus 43. That's an ugly number. Equals negative 57. So let's see. M is being multiplied by negative 25 and then added by 43. So I want to undo that 43. And I'm going to do that by subtracting 43. Still not crazy about these numbers, except, wait a minute, now I see where this is going. As I bring these things down, on the left, the 43 is eliminated. I have minus 25m. Now this should work out nicely for me if I get my signs right. If I mess up my signs here, I have 14, which is not really related to 25. But if I get the signs right, again, these are both two negative numbers. Squish them together, and the answer is negative. Well, if I squish those together, ooh, I get 100. And now we can see the end of this problem, right? If I get the signs right, if I did my arithmetic right, now this finishes off nicely. I divide by the negative 25, divide by negative 25, and m will equal 4. Okay, so right below here, there's a PDF with 12 problems. Try them all. Try each of them, even if they get difficult and you're making mistakes, that's okay. Try them. You should get a nice, neat integer answer or an all real number or no solution, okay? And feel free to go back and watch the beginning part of the video to figure out which time we have one of those. All right, and that's it. And tomorrow, notice on this whole paper, no fractions. Tomorrow I'm going to throw some fractions in, but we'll make your fraction life much easier. All right, have a good night. Have a terrific Thursday, and I'll talk to you tomorrow.